All right, hi. I just feel I just feel being under pressure because I realize that I'm among the last people to present today, and it's not easy. Since Tuesday, I saw people talking about MIMO. Tuesday, MIMO, Wednesday, MIMO, today, MIMO. So before getting here, I questioned myself, what kind of, how to structure, how to recalibrate my presentation to make it useful. Uh, so I changed my presentation many times, and we will see. Hopefully, it will be useful in some ways. Before I start, I, let's see. Hello. So I would love to say thank you to New Radio for many reasons. First, I learned a lot through New Radio. DSP, through MIMO, beamforming, and so on. Without your contribution, I wouldn't be here. Just to let you know, this is my first time to attend a conference. This is my first time publishing a paper, and this is my first time to be on the stage to speak to you. So I would love to say thank you to all of you. Without your contributions, I wouldn't be here. The second act I would like to make is to give credit to someone named Luca Schmidt. I really use some of his work, tools, to build what I have today. Luca Schmidt, I think he was admitted last year, 2018, GSOC, Google Summer of Code, to implement MIMO, multiple input, multiple output. And the beautiful story about Luca and I, so when I learned that Luca was in charge to implement MIMO, I reached out to him and said, can I volunteer to do something? And he said, yeah. What would you like to do? I said, I don't know. And he said, well, why not you just test his code? So whatever he programmed, so I was in charge, reading through and testing, because I have hardware, USRP, so I was able to test his code and learn from what he did. So before, I was not able to build a blog by myself. But because I volunteered to work with him, so today I'm able to produce something. All right, now I will, well, as you see my name, Evariste Some. I'm a graduate student at the University of Colorado. Second year, I don't know yet where this program will end. So I only have two main subjects. Why multiple input, multiple output? So there is a need to understand the motivation behind why are we using multiple input, multiple output. In 1G, 2G, it was only single input, single output. But why MIMO is gaining momentum nowadays? So there is a need to find out the motivation, and from the motivation, so we can improve, see, okay, what are the different techniques that we have nowadays? All right, and I propose two techniques, diversity technique and spatial multiplexing. Because of time, I wanted to add beamforming, but it's in the same family. So, what's the motivation behind multiple input, multiple output? Why are we using multiple input, multiple output? You conveyed with me that each of us, everybody want to have high speed on their cell phone. And to get there, wireless communication provider need to increase the capacity. But how can we increase such capacity with a limited amount of spectrum? Just to remind you, wireless communication system has a big pressure. And you might say, what are these pressure? Everything works fine, right? Think about it. There are more people than ever using wireless communication as a primary source of communication and information. Data requested by user has exploded thanks to new mobile applications such as YouTube, Facebook, and so on. Well, one might say, well, I don't use social media. Okay, fine. The third reason, wireless communication providers are still using lower bandwidth to provide services with a limited capacity. So how can we improve the throughput without using different techniques? So to those who use 1G, 2G, I think they are better off to explain, to give a definition of what's a congestion made, or what the signal performs when the signal starts to degrading. But there is hope, because wireless communication has evolved over the past decade, with each phase bringing its new and exciting capacity, capability, and services to the end user. We went from 1G to 2G by adding SMS. From 2G to 3G, we're able to use the internet. That's fine. 3G to 4G. So that's what most of us are living nowadays. So what was the main difference between 3G and 4G? Introduction of multi-input, multi-output. For 4G, most cellular phones use 2 antennas. Nowadays, we have 4 antennas. And some people are talking about 8 antennas, but we still need time to reach that. So with 5G, when you read the specification sheet, 5G promises high throughput. How can we reach high throughput without using the combination or configuration of multiple antennas? 5G promises to reduce low latency. How can we reach that without using the configuration of a multiple antenna? So to me, not because I researched in multiple input, multiple output and beamforming, to me, I feel like a MIMO is the main piece in 5G. Without using multiple antennas, or what they call massive MIMO, it will be difficult really to increase the throughput. So, what did I do? What do I have to share with you? I learned many publications from you guys. I read a lot through New Radio website. And I came to a point that I need to propose something too. So implementation of multiple input, multiple output using New Radio, using open source. And to do it, I went through our main subject, diversity technique and spatial multiplexing. In a diversity technique, we have, many techniques. In fact, in diversity, what does it mean, in fact? Diversity means that the same signal that you send goes through multiple channels. So you have multiple copies of the same signal. as a result, the probability that the signal will fade is reduced because you are sending out for the same signal multiple copies. So the receiver will effectively receive at least some copies. So diversity, in fact, relies in the strength of diversity is the reliability of communication. The next aspect is multiple input, multiple output. MIMO, by definition, they say MIMO, will increase the throughput. I decided to use analogy. What's MIMO? In this case, for instance, we have a highway. On the highway, we have a multiple lane. So depending on the number of lanes, so if we have a 2-lane, 4-lane, obviously it will increase the capacity, the traffic. The more lane we have, so we can, the flow can go faster. It's the same thing with MIMO. Based on the number of antennas we have, it from a base station to a receiver, so that we increase the throughput. So with 2x2 MIMO, we will increase, in theory, single input, single output. With 4x4 MIMO, we will increase the capacity of 2x2. Now, something to adjust. In this figure, we have a base station and a cell phone. Apparently, things look straight. MIMO, in fact, doesn't work without multipath. So the thing to remember, it's just a way to picture the number of antennas we need from a base station and what a client needs. If a client is capable to have 2 antennas, obviously the base station will dedicate 2 antennas to communicate with. If it's 4, the base station will dedicate 4 antennas to communicate with the client. That's the idea. Otherwise, signal don't propagate in a straight path from the base station to the client. It doesn't work. MIMO only works in multipath. And that's one of the reasons in a rural environment we are still having problems to implement successfully MIMO. So, in diversity technique, what I did is to use some tools to build this algorithm, Alamuti. Many of you know about Alamuti code. So this is part of Luca Schmidt work. So using encoder and a decoder. The next one was to use selection combining and maximum ratio combining. In selection combining, the algorithm is pretty simple. In fact, selection combining select the signal with the high signal to noise ratio, and pass that for decoding. Maximum ratio combining is a kind of complex algorithm, but it has its price in terms of performance. So putting this together, I was able to build an application and measure the output of Alamuti selection combining and a maximum ratio combining. Obviously, in theory, it said MRC has an effectiveness above selection combining and Alamuti. One question that very often comes every time is why or how to choose a particular algorithm, either selection combining or maximum ratio combining. It depends. It depends, because you need to make the trade-off between complexity, right, and the performance. It depends the situation. So if power consumption is not a big price for you, so you can make your choice. In spatial multiplexing, so I use zero forcing and MMSC, minimum mean square error. So zero forcing cancel ISI, the ISI inter-symbol interference. Yeah. So it's cancel inter-symbol interference and multiple access interference by designing a Nyquist pulse, or you can use equalization, to compensate the thing. MMSC is, in fact, it's an extension of a zero forcing, but optimize the signal to interference, the price to noise ratio. Okay. So using a decoder, encoder first for zero forcing and MMSC, and for the decoder, in fact, we can see that we have a minimum mean square error. In fact, you can select either MMSC or zero forcing depending on the type of algorithm you want to use. All right. So going through simulation, why new radio is awesome. On the same page, so as you can see, we have some constellation. I put some option, for instance, to vary the energy per bit, and you can see the bit error rate of performance, and also a real-time display throughput. One of the issues I got to this point, I use a USRP N210. In theory, they said you can receive up to 25 megasample per second. But for some reason, my USRP N210 couldn't pass 5 megasample, even after recalibration. Yeah, I questioned myself, but it's a school. These USRP have been overused. But I'm still looking for ways to improve my hardware. So if anybody has a way to, to pass at least from 5 megasample per second to at least 15, that'd be great. So after implementing zero forcing and MMSC, so also I compare the performance. So the performance has shown that MMSC effectiveness over zero forcing. But at high F0, we can see a convergence of zero forcing to the same level than MMSC. So what to remember to this? The growing demand for high data rate increases the need to utilize spectrum more efficiently. It's true. Nowadays, we have higher spectrum. But if we don't learn how to use efficiently lower bandwidth, I don't think we will be able to use efficiently upper spectrum. And upper spectrum has its costs, too. The second thing is using multiple antenna configuration. It can be used to overcome the detrimental effect of a signal, multipath, and fading. Depending on the type of implementation you want, it can be a diversity or MIMO. And there are many algorithms in diversity as in a multiple input, multiple output. Lastly, implementation of a multiple channel using new radio is widely use and support wireless communication research. I went from nothing, but thanks to New Radio, I improved myself in how to implement a blog, how to write, from given mathematical formula, how to represent that using a blog. So there is no question you will post on New Radio and you don't have answer. So if I can do it, I believe you guys can do it too. So I think that's the end of my presentation.
Well, I'm thrilled that you chose this as your first conference. I truly am. And I'm doubly thrilled that you got in touch with students from my alma mater in Karlsruhe. So that's cool. Yeah, do we have any questions for Evariste on MIMO? We have one at the back.
Can you repeat the question for me?
Of course.
I did.
Sorry, it's more of a suggestion just for something if you want to take a look at it, but transmit antenna selection, just like a reduced complexity version of MIMO, where instead of transmitting on all of the 4 transmit antennas, you could choose one of them and send data that way.
Yeah, okay. Complexity versus performance. Well, it depends on your application. It depends on what you want to focus on. Obviously, if the complexity, like when you take an MRC comparing to SC selection combining, if implementation of MRC doesn't cause you too much cost, I think you can go forward with MRC. Yeah.
Do we have any more questions? Was there a hand raised? No? Okay, I have a question. It's not exactly about MIMO though. It's more about choosing GNU Radio as a tool in university. I often debate with people at universities about using GNU Radio, and the argument usually goes this way. It's like, like when people use GNU Radio, they also have to learn Git and C++ and all those things, and we just want to teach them communications. And I say, no, they have to learn Git and C++, and that's good. So, there's a bit of an overhead with learning GNU Radio. Well, do you think that's an impediment to your work? Do you think that's ultimately useful?
When I came to New Radio, frankly speaking, I started using blogs. You just move the blog and interconnect them. But later on, I wanted to build something on my own. So for those who use the New Radio website, there is a process, step by step, how to build a blog. It's not difficult. Well, you have 2 ways. If you can program in Python, that's fine. Otherwise, you have a C++. Either one is not complicated. You just need to practice. What's difficult is come to understand the algorithm, what the algorithm does. For instance, when you take an MRC, find out a book. There are plenty of algorithms on how to do it. So when you have the algorithm, the remaining, I think, is a step by step. That's how I went from using people code, and then later on, look for to design something on my own. So it doesn't happen one day. So it takes time and be patient in learning.
Okay, well, I think we can have one final round of applause for all speakers today. And